so day 10 is going to be due Monday. All right, we're taking the mock exam on Monday, but I'm going to make these answers available before then. But this is how you should have this done by then, okay? Some of these are pretty straightforward. Like, we're not going to do problem number 1, but I do want to say this. If you get a problem like 1, that's an easy problem that everybody should get. Don't mess up because you're rushing through it, okay? The other thing is, if you do a problem and you're sure you got the right answer, but it does not match any of these, don't be afraid to pick E. All right? On SAT test, E, none of the answers is correct. That's never the right answer on the SAT test, okay? Or has it been since like one problem in the 70s? So, but on the AP test, definitely you could pick E. So don't be afraid to pick E. All right? Especially if you know you did the problem right. Okay, all of those are pretty straightforward. Let's start with number 6, all right, which is on the second page. So on number 6, we have this integral, and it's kind of messy, all right? You might be thinking U substitution, but even so, you can clean this up a bit. And so watch what I'm going to do here, and this will kind of remind you of some of our strategies. The first thing I'm going to do is rewrite the radical sign as to the 1/2 power. That's what we always do. The radical sign is not friendly, 1/2 power is friendly. Okay, because the denominator is just one thing, I can split up the numerator. Okay, so I can split this up into x over x to the 1/2 plus 2 over x to the 1/2. It's on the second page. Okay. That's okay. There's not a whole lot of space between 5 and 6. Okay, so can I simplify this further? Can I use algebra to make this even more simple? Like, can you simplify that?
You can move the x up.
Okay, so if this was x to the 5th over x squared, what would you do? And how'd you get that? You subtract the powers. So that's what I'm going to do. I'm going to subtract the powers. 1 minus 1/2. This right here is a lot easier to deal with. Okay, the second one, I am just going to rewrite it kind of like what Brett was saying. Move that up to make it a negative. All right, now I no longer have any fractions to deal with. This is why this is making this easier. So it's the algebra here that can make this problem easier. All right, and so remember, using the power rule, you add 1 to the power, and then you put the reciprocal in front. So if I stopped here, I would think, hey, the answer is A, right? But do I know for sure the answer is A? Yes. Okay, so don't stop there, in other words. Okay, keep going, because it could be that none of the answers are correct. All right, so I'm just going to put the 2 here. If you're not good with doing this in your head, just rewrite the number, leave a space, write your x, add 1 to the power, and then take the reciprocal of your new power and put it in front. It's the reciprocal of the new power. Because if you think about it this way, if I were to derive this, 1/2 times 2 would be 1x, and then to the negative 1/2. So, is the answer A?
Yeah.
Yeah, it was. Okay, but when you have an answer choice, none of the answer choices is correct, don't stop until you know you have the right answer. Okay? Number 7, I'm not going to work this one, but look at your answer choices. Okay, by the way, this is the same as this. They're both arctan. So what does this make you think of? The what? Yeah. Well, I don't know if this is what you mean. But all those little green cards? I will say that as far as the AP test goes, there's some that pop up a lot more. Arctan and arcsine are the ones that show up a lot, not a lot, but more frequently than like arcsecant or any of those. So I would focus on those two. Okay? All right. I'm going to let you look that up. You have it. You could Google it if you don't have it. All right, let's look at number 8. So I'm looking at this problem. Can I split this one up the same way I split up number 6? No, because you can't move the x and the 3 separate in the denominator. So what can you do?
Use substitution.
Okay, so there's a couple different ways to do this one. I heard use substitution. What would you let u equal?
X plus 3.
X plus 3. Then what would du equal?
1.
Dx.
Yeah, 1 dx. And if there was a number here, we would divide it.
You
And
get X.
so
Token.
So you get this, and there's what do we do with the x? It is a TOCO. So this would become x equals u minus 3. And now you could split it up. Do you see the difference?
Yeah.
You could split this one up into, so u over u minus 3 over u du. All right, now I'm going to stop here because I'm going to have you finish this problem, but I want you to see another way we could have done this problem. Anytime you have a fraction that you can't split up, you may want to try long division. Now in this problem, long division is really not that difficult. You just do denominator into numerator. X goes into x one time. 1 times x is x. 1 times 3 is 3. Subtract. Remainder is negative 3. So this becomes minus 3 over x plus 3. In other words, this is what you are trying to integrate. So it kind of looks a lot like this one up here, right? So it's very similar. It just depends on kind of how you are. Are you going to think to do TOCO, or are you going to think to do long division? It's good to kind of be familiar with both, and then, but you definitely probably have your preference. So I want you to go ahead and finish this one and find the answer. And even if you're kind of getting stuck, at least cross off ones you know are wrong. Because there are 2 on here that are blatantly wrong. So we got it? We need more time? What do you think?
I just want to see this stuff.
Hmm?
I just want to keep my head on this stuff.
Okay, so I'm gonna, from here, this part would obviously be x. That's why I went ahead and crossed off a and b. Now to integrate this part, that means I really need to integrate this because I can pull out that 3. So out of c and d, I know it's d over c, right?
Mm-hmm.
Okay, the big question then is d right, or is there not a correct answer? Okay, integrating this is going to be a u substitution the way it is right here. You would let u be x plus 3, and so then you're integrating 1 over u du, which is natural log of u. And since u is x plus 3, the answer is d. I do...
So, sorry.
Go ahead, no, go ahead.
Oh, okay. So whenever, if you did it with the red, you would, that would equal 1, okay, and then it would be the same thing. You would just plug in x plus 3 back for you.
Yes, but I do want to say something because some of you might have figured this out. I don't know, maybe not, but this would actually be x plus. If you did it this way, it would look like this. So my question is, why are these the same?
Let's see. Combine.
Exactly. Plus 3 plus c, is that not just still plus some other number?
Yeah.
And so that they were probably not anticipating you doing it this way, right? But it's the same thing. I just am afraid some people might want to take e because they're like, oh, there's no plus 3. All right.
Why is u over u just u? Why is it not just 1?
It is 1, but then you integrate it.
Which is u, which is x.
Oh, really?
Yeah. This was 1, and then the integral of 1 is u, which is x plus 3. Okay. Move on to number 10. All right, another thing about u substitution is anytime you have e to a messy power, you let u be that messy power. And so in this case, u is going to equal sine x. This is something you always want to do. E to square root of x, u is the square root of x, and so on. All right, and what you're hoping for is that your du is all the other junk there. Okay, which in this case it is, because the derivative of sine x would be cosine x, and then dx, and then this right here is that other part. So by doing a substitution, I have integral e to the u du. Everything's substituted perfectly. There's no extra, there's nothing missing. All right, what's the integral or antiderivative of e to the u?
U.
E to the u. Plus c, although that doesn't really matter on this one. They all have it, and so my answer then would be C, because u is sine x. This also would be a really good one if you were kind of getting stuck to do guess and check. So how would the guess and check method help you?
You find the derivative of the answers.
You would take the derivative of each answer and see that it equals this. And remember, when you take the derivative of e to some power, you just rewrite it times derivative of that power. Okay, turn to number 18. This is the last one we're going to do.
Number
18. All right, so they say we have a function f, differentiable just means that they can take the derivative for all numbers. We have a point, 3 1/4, that just gives us an x and a y value. And on this graph, and the slope of each point is given by this derivative. Okay, and we know that derivatives are the slope of the tangent line, so that makes sense. So on A, it's asking us to find d squared y dx squared, which really is just the second derivative. Okay, well and then we're going to evaluate it, but first we just got to find the derivative. All right, so this means we've got to derive this part right here. What rule am I going to have to use to derive y squared times 6 minus 2x? Product rule. So derivative of y squared would be 2y dy over dx, then just the second term, plus, yeah, then you just write the y squared, and then what's the derivative of 6 minus 2x? Negative 2, and you don't need anything. It's only, on these problems, only when you take derivative of y do you need the dy over dx. Now, the only thing you need to make sure you do from here is that dy over dx, we need to substitute that in. And this is going to happen every time you do the second derivative. So this ends up being 2y, and then in place of dy over dx, I've got to actually rewrite this. Y squared 6 minus 2x. And then I had another 6 minus 2x plus y squared negative 2. The beauty of the free response questions is that you do not have to simplify. Okay? Now, we're not done though because they want us to evaluate at that point. All right, so I'm going to do this underneath here in red. Yeah, so I'm going to plug in 1/4, and don't get all in a hissy about the fact that you might have to square 1/4. This actually works out very nice. I'm plugging 3 in for x and 1/4 in for y. Now truly, you could just circle that and be done. But I do want to show you how easy this is to simplify. 6 minus 2 times 3, what is that? 0. So that whole thing is 0. So really, even if you had to simplify this, you're just doing a 16th times -2. I'm going to write my answer up here so I don't go too much into part B space. Okay, so that really wasn't the new stuff. That was just kind of more of the old. We've already kind of talked about second derivative a little bit. All right, now part B, this is not the new, but this is day 10 stuff, integrating. So instead of asking us to derive, they're asking us to go backwards just to find the original function given the derivative. Then we're going to use the initial condition to find plus c. So what do you need to do before you integrate this?
Get the dx on the other side.
I need to get the dx on the other side, and y squared needs to go to the other side. You have to have your this is called separation of variables. You have to have your variables separated before you can integrate. We've learned how to derive with mixed variables, but we do not, nor do we care to know how to ever integrate with more than one variable. Okay? So now you're able to integrate. And by the way, the 1 over y squared, I'm going to rewrite that as y to the -2. Probably something I see a lot is students know that the antiderivative of 1 over y is natural log y. So they think, hey, integrate 1 over y squared, that's natural log of y squared. But it doesn't work that way. All right, this is actually the simpler case. Okay, you just add 1, and then you put the reciprocal. And I'm going to just leave 1 plus c on the other side. 6x, I'm just doing antiderivative. I'm going to erase that just so it won't be confusing for y'all to see. Oh, that's not what I meant to write. Plus c. Okay, so now we have kind of two things that we need to be doing. We need to get y by itself, and we need to find c. You can actually do this in either order. I have always shown y'all to get y by itself first, because we can be super loosey-goosey with this c until we plug in the numbers. And when you plug in the numbers, c is set. It does not change. So first, let's think about, okay, y to the -1, that's 1 over y. But what would be the easiest way to get rid of this -1? How do you get rid of -1?
Divide.
Divide or multiply? I mean, really, this is what it does. It changes the signs. Now, I'm not going to change the sign. And c is just some number. If you divide by a negative, it's still just some number. It's a different number, but it's some number. All right, and then if I'm going to get y by itself, if 1 over y equals this thing, then just y should be 1 over that. If that's confusing to you, another way to think of this is just by cross-multiply and divide. Like, if I put this over 1 and I cross-multiplied and I divided, you would get what I've written here. Okay, so this is our differential equation, and now what we need to do is plug in the x and the y. I'm going to actually do that just down here, just to kind of, sorry, I'm taking up so much space here. And by the way, on the AP test, you were given about half a page to do all of these. They give you a lot of room to do your work. I just wanted to not use a ridiculous amount of paper, only slightly. So we need to go ahead and plug in the 1/4 in for the y, and we need to plug in the 3 in for the x. And one nice thing about this is, okay, if 1/4 equals 1 over this, then shouldn't 4 just, I mean, the denominators have to be equal if the numerators are. So the whole 1 over, you can ignore that. Although cross multiply, you know, would have worked as well. But I want you to go ahead and do what you need to do to find C. And this is a no calculator problem.
This might be like a dumb question, but like on the free response, do we have to use like pen? Or
No. And I suggest you use pencil. If you erase or scratch out, they will not grade it.
Okay.
If you leave it there, they will grade it.
Okay.
So, like, if you start something and it's wrong, you need to erase it or scratch it out.
Okay.
And some of that we're going to talk about after we do the mock exam. I'm going to see kind of what y'all do and address some of those things.
Okay.
The bad thing is, if you had something good and you erase it, even if the grader can tell, oh, they were onto something, they could have gotten a point from that, even if they could see it. If you erased it, they won't grade it.
Mm.
So you don't have to worry about erasing so well.
Right.
Just erase or don't erase. All right, what are we getting for C?
13.
13 is correct. Lucky 13. All right, so that was one of those that we call these differential equations. There's a few more on here that you'll get to practice. Okay, this is all that chapter 5 stuff that we did before the volume.